Hi everyone, my name is Carolyn and this is Julia, Rachel, and Julia, and we'd like to introduce you to Chrysalis. The current global opioid crisis continues to escalate, and one of the most devastating effects of this is neonatal abstinence syndrome, describing the withdrawal symptoms experienced by infants of opioid-using mothers. There's been a 200% increase in NAS diagnoses from 2010 to 2017, and treatment for this disease has cost the US healthcare system upwards of $563 million each year. Current treatment is based on a combination of replacement opioids and non-pharmacologic treatment, but because of the detrimental effects of long-term opioid exposure, there's been a push towards favoring these non-pharmacologic options. The current gold standard for promoting such treatments is the Eat, Sleep, Console model for NAS severity assessment, which is based on the infant's ability to eat, to sleep, and to be consoled. This is because it's been clinically proven to decrease average length of stay by 16.5 days, decrease the total number, or the percentage of infants needing opioid treatment by 84%, decreasing the total cost per patient by $34,500. However, speaking to nurses at HUP and CHOP, we found that it's been extremely difficult to implement ESC in hospitals because of the lack of parental involvement and the ability to implement measures such as swaddling and skin-to-skin placement in this particular patient population, as well as the time-consuming and tedious nature of ESC documentation. Therefore, there's no product on the market clinically able to alleviate NAS treatment, there's currently no product on the market capable of alleviating NAS symptoms without pharmacologic treatment that integrates smoothly into the current care workflow.
Our solution is Chrysalis, a comprehensive tool to soothe these NAS infant symptoms and simplify the ESC documentation process through a smart swaddle and a companion iPhone app. Chrysalis supplements current non-pharmacologic treatments by replacing mother-infant interactions such as skin-to-skin contact and rocking through the physical swaddle and the vibrational motors sewn into it. These vibrational motors extend infant sleep time and decrease the time it takes to console them, thereby decreasing the need for pharmacologic intervention. Additionally, the companion iPhone app can remotely stop and start these vibrations, as well as quickly document ESC vitals, reducing a main barrier for implementation of the ESC method in hospitals. Our physical swaddle is 25 inches wide with the flaps out and 30 inches long, which is the size of competitor swaddles. The electrical sleeve within the swaddle is 100% waterproof and electrically insulating. Babies can be messy, so we don't want any fluids to get on the electrical components or any of the current to come in contact with the babies. For our proof of concept in October, we had an imagined layout of our swaddle, which we then sewed together for our minimum viable product in February. Since then, we've resewn this product to be a little bit larger and also made of softer, more comfortable fabric. This is our final prototype. There are buttons going down the center of the swaddle to easily get the baby in and out, and flaps on either side that can fold in over the infant's chest. On the left flap, there's a zipper that, when unzipped, contains the electrical sleeve with all of the device's electrical components. As you can see from this video, when the flaps are folded in, they're large enough to cover the infant's entire chest, so we only need this electrical sleeve in one of the flaps. Additionally, we designed the flaps to not be so long as to restrict infant mobility in the hip region. Within the electrical sleeve itself, for our proof of concept, we had all of the device's electrical components separately working on different breadboards, which we were then able to integrate into one proto board for our minimum viable product in February. Since then, for our final prototype, we designed a printed circuit board to eliminate bulkiness in the swaddle and streamline our flap. This printed circuit board contains a 1010 MKR Wi-Fi Arduino microcontroller, as well as an H-bridge that controls the 8 vibrational motors. In addition from switching to a proto board to a PCB, we also switched from traditional vibration motors to e-tech style motors, which can be connected to this PCB through conductive thread and allows these motors to lie even flatter within the sleeve. This sleeve is also encased in electrically insulating and waterproofing vinyl. The second main feature of our device is the 2 vibrational sequences that run for 15 minutes each. The first vibrational sequence mimics the maternal heartbeat that infants can often hear and feel in utero, and is clinically proven to soothe infants who are irritated and crying and get them to decrease their crying time much quicker. As you can see from this graph, the red is an actual maternal heart rate output, while the blue represents our motor output from our Arduino microcontroller. The T wave of a maternal heartbeat is about 38% as intense as the QRS wave, so we wanted to model that pattern in our motor output as well. The second vibrational sequence is a stochastic resonance sequence. And stochastic resonance is basically random white noise at varying frequencies and intensities. This vibrational treatment is shown to lull infants who are on the verge of waking up back to sleep. Our 8 vibrational motors that you saw a few slides ago are divided into 2 groups of 4. So as you can see on this graph, we have the 2 groups in red and blue, and they're each vibrating within their own range of intensities, but at random intensities and frequencies over time.
Our next device component is the Wi-Fi connection between the Swaddle and our accompanying iOS app. For our proof of concept, we used a Bluetooth connection between a pager and our Swaddle to notify nurses of infant distress. For a minimum viable product, we replaced that pager with an iPhone iOS application that connects to our Swaddle via Wi-Fi. This pivot to Wi-Fi allows for the connection to span a wider range and allows the nurse to stay connected to the infants no matter where the nurses are in the hospital. And for our final prototype, we use this Wi-Fi connection to connect multiple Swaddles at once to a single application, as a single nurse would manage multiple infants in a hospital setting. Now on to the accompanying iOS application. Nurses currently use iPhones in their day-to-day workflow as they receive notifications and document information on their iPhones. So our app will fit seamlessly into that workflow and renders this Chrysalis Smart Swaddle system accessible. For our proof of concept, we began with the pager. For the minimum viable product, we planned a mock-up of what our final prototype of the app would look like, but we're only able to code about 1 interactive user page. So then for our final prototype, we were able to finish coding the pages we had set out to and added some key functionalities that would help make ESC documentation easier. Now in this next slide, we're going to quickly walk through the app. After you see the launch page, you land onto the list of infants, and the nurse can click on infant 1 and view their key metrics and previous ESC assessments. Then they can navigate to administer the vibrational treatment, which automatically triggers a timer to document the length of treatment and also documents the timestamp and date of treatment. The nurse can then turn the treatment off, which will automatically stop the timer, and the nurse can reset the timer if necessary. These capabilities are the same across all infants and allows the nurse to manage multiple infants at once.
So to emphasize the progress that we've made from our MVP to our final prototype, we'll highlight that back in December, we had 2 clinically supported vibrational sequences. We had also created a physical swaddle with integrated but very bulky circuitry and had a preliminary iOS application. And then for our final prototype, we had refined those vibrational sequences, upgraded our circuitry to use e-textiles and that printed circuit board for a flat, soft electronic sleeve, made significant progress in coding our application, and also begun our user testing. So for our human factors testing, we conducted a survey directed to nurses on the functionality and practicality usability of our app design. When we asked nurses, how did you feel about app navigation, 88% of them said it was very straightforward. And when we asked about functionalities of documenting things like timestamp and duration of treatment, as well as automation of ESC documentation, our overall satisfaction with those features was a 9.3 out of 10. So those are pretty positive results and give us a good indication that we're ready to move into our validation and verification of our project. So for this validation, because it's really hard to get IRB approval in a COVID setting, and really for neonates even outside of a pandemic, our preliminary testing will instead be done in a controlled, non-clinical space, getting data from well babies with the assistance of our mentor and other hospital connections. We also plan on hiring a software engineer to help us store ESC documentation information, and we'll move forward with filing a patent on our project. So for this preliminary testing, we'll give the Swaddle to parents to use on their healthy babies for an established period of time, and ask them to give us feedback on the efficacy of the product as a standalone Swaddle and also in conjunction with the app. And we'll be looking for some key data parameters that we'll be collecting. The first is temperament with and without the Swaddle. We'll ask parents to give us, on a scale of 0 to 10, what their baby's behavior is typically like, 10 being a really, really happy baby, 0 being a very unhappy baby, in order to ensure that our Swaddle isn't causing any discomfort to the infant. We're also going to be collecting consoling time with and without the swaddle, with the goal of a 15% decrease due to the vibration treatment. And finally, the total duration of vibration, because it'll be the first time we'll actually be testing on an infant. We want to make sure it works okay and see how often it's used within a 24-hour period. So after we've validated our product, we will move to more rigorous testing and also implement a go-to-market strategy. The first thing we'll do is submit the app to the App Store. We will also explore integration with hospital information systems like Epic in order to be able to share that electronic medical data. Finally, we will scale up to have in-depth hospital implementation. In going to market, our Swaddle and app system will be the first of its kind to treat NAS without pharmaceutical intervention while easing ESC documentation by integrating smoothly into current care workflow. We at Chrysalis are passionate about alleviating the burdens that NAS imposes on infants, parents, nurses, and hospitals. We'd like to thank everyone in the Penn community for helping us develop Chrysalis, and also these organizations for acknowledging our work in various competitions. Thank you. We will now take questions.
First of all, great presentations. Like, there were so many times that I had questions in my head, and the next slide answered that question. I'll also say I have a 4-month-old, and the idea that having a thing that vibrates on them is going to soothe them, 100% correct. Are there any other, so 2 questions, are there any other devices out there that are doing this sort of like, vibrating a child in response to something? And are there any kind of, negative effects of, like, I don't know, over vibrating a baby? And then, sorry, the second one is, you talked about filing a patent, right? So if have you already sort of talked to a patent attorney? Because if you have a public disclosure, which I'm not going to claim whether this constitutes one or not, that may inhibit your ability to file broadly. So have you given that thought as well?
Sure, yeah. So in developing our product and our idea, we did look into potential competitors, but what we've seen is that there's maybe a mattress out there that gives stochastic resonance frequencies to help with infants and help it with their sleep. However, there hasn't been anything that we've seen out there that has both a maternal vibrational sequence that mimics the feeling in utero in conjunction with the stochastic resonance frequencies. So in that way, it's very novel. And to answer the second question that you had, we have been speaking with some potential patent attorneys, and they let us know that we have 1 year post public disclosure to file a patent. So we've been working on that in the background. Do you want anything to say?
And then one additional note about competitors. So like Rachel said, there are a couple things out there that are starting to explore vibrations, but there's currently nothing that's targeted towards neonatal abstinence syndrome, and also there's nothing that's working towards this ESC documentation. And so having the app will hopefully be a very, very unique aspect of our product.
I loved your project, use of sewing and everything. One thing I was wondering was that you said you were making this waterproof by incorporating vinyl. I was wondering what thoughts you had given towards the potential for overheating, since vinyl is non-porous and heat trapping potentially to the baby.
That is a great point. We we have been thinking about and exploring potentially different materials to work with. We also were thinking about eliminating somewhat of a cover and finding something that's a little bit more insulating and waterproof in and of itself without the vinyl cover. So that is something that we have been thinking about. But that's a great point. Yes.
First off, great presentation. I thought that the features you've added are incredibly thoughtful, especially towards nurses who might be overseeing this. One question I had is, today when you're thinking about the ESC standard, how long is that typically happening for? And the reason I'm asking that is I'm wondering, throughout the course of someone using this, between the interactions of the nurse and parents, what that might look like throughout the duration.
So this is an example of the form that nurses currently have to fill out, like at the bedside, after every time they interact with an NAS infant. For the Eat, Sleep, Consult method, So as you can see, it's extremely time consuming, and like there's just a lot of moving parameters. And so from our conversations, this adds a lot of time, as well as like having to transfer this into an electronic system at the end of the day adds a lot of time to the nurses and a lot of burden to already overworked nurses. And so our plan is for our app to be able to fill out a similar questionnaire very quickly just on the iPhone and have that immediately integrate into the medical records.
And to answer the question about the parental involvement, this particular target population struggles with having involved parents, which again puts more of a burden on these nurses, which is why it's critical to reduce the amount of time for documentation. So yeah, typically it'll be less involved with parents.